Hey there, I'm Juancho. I'm your guide in the upcoming game development course. Uh, I'm in Vancouver. I've been in and out of the game industry for a number of years, and I will talk to you today about 5850, the Building Game Engines course here at Northeastern University. We are going to be looking at modern game development from the perspective of understanding how game engines work nowadays. There's two particular open source game engines that you will be able to use for your final project. But what we are going to be doing in order to get you to understand how it all works is we're going to build a game engine in C++ from scratch. I expect you to be using LLMs in this course. I will be giving you examples, and I want you to think about the systems. And one of the things that's going to be very different about this course is we are going to be test driven from the very beginning. So every system that we build, every component that we build is going to be tested. This is somewhat different from other approaches in the games development community. So we are going to be talking about the ECS architecture. The ECS architecture is a recent, in the last 15 years, development that allows computers to deal with hundreds, if not millions, of entities in a game. So an entity is a container. It's just a pointer to something that the systems deal with. Entities have components, position, they have velocity, they can have health, whatever. And then systems are uh, standalone systems that look over the entities and update the components in those entities so that you can do movement and stuff like that. In order to make this all work together, we have a blackboard where the different systems can write and read things there. Um, there are two open source game engines that I told you about before: Bevy, which uses Rust, and Flex, which uses C and Unity, and other modern AAA engines or work. We are not going to be doing object-oriented programming, no behavior hierarchies. It's pure systems and data from the first class. We are going to introduce the idea of test-driven development with what I called ETL. Basically, what you can do is you can set up within your system different entities to have different properties. Then you can run a system over that, and then you can see what the output is. And that way you can make sure that the systems that you're building are actually doing the right thing because you've written the tests first. This is roughly how we're going to be approaching this. We'll do the foundations, and first three lectures will get you set up so that you have a window, a render system, some sort of timer, a heads-up display, and we'll talk about testing. Then we'll talk about input, collision, game state, and the resource manager. Then we'll start looking at how these things apply to games. We'll have a duck shooter, asteroids, some sort of match 3 game. At this point, you'll start to think about what your final project is. You'll be able to work individually or in teams. And then we'll look at integrating some engines or some libraries from the real world: physics, audio, continuous integration, continuous deployment, and engine QA. But by this time, you'll see, because we started with testing, a lot of the engine QA is already done. And then you'll all present your projects at the end of the semester, and we'll have fun playing them. This is intended to be a modern game engine development course that will allow you to, on your resume, indicate that you understand how game engines work. In particular, you understand the ECS architecture, which is what Bevy and Flex use. You are going to be managing thousands of lines of code with AI tools. This is how the modern world works, and it's an important skill for you to develop. This is subject to change to when the course gets launched, but roughly 40% of your grade is going to be assigned to weekly workbooks that I will be handing out. These are step-by-step coding within the engine exercises that allow you to understand the systems that you're building. We'll have some sort of minimum game. Well, I'll define a game and you can pass the test. And then a final project, which is worth 30% of your grade. The final project actually has to work in order for your course to be graded appropriately. And then there's some sort of participation in quizzes and retrospectives and reviews, etc., etc. I expect you to use LLMs here, but one of the ways that I'm going to help you learn in this course is I will give you, for each assignment, a rubric, and then I will give you an LLM evaluation prompt such that you can run your tools and the tests, and then you can run the LLM evaluation prompt over your code, and that will give you a grade. You can then examine the feedback from that prompt. You can run that as many times as you want. Once you're happy with the grade that you're getting, you will submit it. We will validate that these assessments are correct, and then that's so you'll always know what grade, kind of roughly what grade you're going to be getting for your assignments as you hand them in. What do you expect from this? I would like that you understand some object-oriented programming. We're not going to be doing a lot of object-oriented programming, but data structures and algorithms are important. If you don't have C++ experience in this day and age, the LLMs will help you. I do expect that you are going to be self-learning. This is not a C++ course. I'm not going to talk about pointer arithmetic. I'm not going to point about allocating new systems. I expect that you have the curiosity and the tenacity to go in and learn this by yourself. You should also be comfortable with running things from the command line. Your time commitment is 12 to 15 hours, as per most grad courses. There is a lot of material coming at you in this course. So that's why I have these workbooks that I will be handing out to you. Each workshop will require you 2 to 3 hours to work through it. And then there's assignments as well that will be handed out. That ramps up towards the end of the semester. There are some textbooks out there. There's the game engine architecture and the game programming patterns. However, you don't need those. I suggest them. If you get them, that'd be great. Great references. However, I will be handing out in a mono repo. I'll update the URLs closer to the course, since I'm at this point preparing it. How do you get started? Make sure that you have GitHub Copilot or Cursor or Cairo or Claude Code on your machine, and that you know how to use these. Why is this course? What is different about it? I want you to learn how to use LLMs in the context of building systems that you've never seen before. I want you to understand what the ECS pattern is. I have been doing some research on how to do testing for ECS systems, so we're going to incorporate that into the course. This is, as I said, not a C++ course, but you will learn how to read C++. You can use the LLM to do that. You'll have 3 complete games, and then your final project, and also an assignment game that you'll be given as well. So let's build some game engines, and come and join me for the summer. I really look forward to seeing what kind of games you can come up with. Thank you. Bye.